In this video, let's discuss the basics of probability. What do we mean with probability? Probability is the chance that a given event will occur. Now, there could be no chance for the event to occur, or there could be 100% assurance that the event will occur. Now, in the case where there is no chance for the event to occur, we say that the probability is equal to 0. And in the case where there is 100% chance for the event to occur, that is, it is assured that the event will occur, we say that the probability is equal to 1. Therefore, the probability will always vary between 0 and 1. Alright, now let's see how we calculate probability. Probability is nothing but the ratio of the favorable events divided by the total events. Let's take an example to understand this. Say you are tossing a coin and you want to find the probability that you get a head. Alright, now that, as we've seen over here, is nothing but the chance that the outcome of this event, which is tossing a coin, is heads. Now, probability of getting a head is equal to the favorable events divided by the total events. Now, how many favorable events are there? There is just one favorable event, which is getting a head. And how many total events are there? There are two possibilities, right? You could either get a head or you could get a tail. So there are two possibilities, which is head and tail, and there is only one favorable event, which is getting a head, because we are trying to find out the probability of getting a head. Alright, let's take a few more examples to solidify our understanding of what we mean with probability. I keep this aside. Now, say you are rolling a dice. A dice is used to play games like Ludo, right? So this is nothing but a cube on which the numbers 1 to 6 are written on different faces, right? Now, let's find the probability of getting 3 when you roll a dice. Now, remember, probability is favorable events by total events. How many favorable events are there? There's just one favorable event, which is getting a 3, right? Because we are trying to find the probability to get a 3. And how many total events are possible? You could get the number 1, 2, 3, 4, 5 or 6, right? So there are 6 total events that could happen. Therefore, the probability of getting 3 is equal to 1 by 6, right? That is, this one over here is the event of getting a 3 when you roll the dice, and this 6 over here are the 6 possible events. That is, you could get 1, you could get 2, 3, 4, 5 or 6. So the probability to get 3 when you roll a die is 1 by 6, or you can say that the chance is 16.67%, right? If you do 1 by 6, you will get the value as 0.1667, and that is 16.67%. Alright, now let's also find the probability to get an even number. So it's the same case. We are rolling a dice and we want to find out what is the chance to get an even number. Alright, now again, probability is favorable events by total events. How many favorable events are there? There are 3 favorable events, right? And the total number of events is 6. Which are these favorable events? If you get 2, 4 or 6, right? If the outcome of rolling the die produces a 2, a 4 or a 6, you get an even number, right? So there are 3 favorable events. That's this 3 over here. And there are a total of 6 possibilities, which is getting 1, 2, 3, 4, 5 or 6. Therefore, the probability to get an even number is 3 by 6, which is equal to 1 by 2. And therefore, we can say that the chance to get an even number when you roll a die is 50%. Let's do this question. In box 1, there are 20 red balls and 10 blue balls. A ball is drawn at random. What is the probability of getting a blue ball? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. So we have box 1 over here, and it's mentioned that in box 1 there are 20 red balls and 10 blue balls, right? And we need to find the probability of getting a blue ball if one ball is drawn out at random. Alright, that's the question. Now remember, probability is nothing but the favorable events divided by the total events. Now In this case, how many favorable events are there? You could be picking any of these 10 balls, right? You would get a blue ball out. Therefore, the favorable events are 10. And what is the total number of events possible? You could be picking any of these 10 plus 20. That's 30 balls. So 10 plus 20 is the total number of events that are possible. Therefore, the probability to get a blue ball, which is equal to favorable events divided by total events, is equal to 10 divided by 10 plus 20, which is equal to 10 by 30 or 1 by 3. So we can say that there is a 33% chance to get a blue ball out if you are drawing a ball out from this box over here. In this video, let's discuss about or and. So these are two words that you will see in many questions related to probability. And we have already seen this in the case of fundamental principle of counting when we discuss permutation and combination. Alright, now let's take an example to understand these very well. Say a dice is rolled. Alright, and let's define two events. Event A is the event where a multiple of 2 is the outcome. Event B is the event where a multiple of 3 is the outcome. So what are the possibilities where event A is satisfied? We could get 2, 4 or 6 as the outcome of rolling the die, right? And what about event B? The cases where event B is satisfied is when 3 or 6 is obtained when you roll the die. Alright, now whenever you do some type of questions in probability, it's very helpful to draw a diagram, and you can see more of this in Venn diagram section. But over here, let's quickly understand only what is required in the case of probability questions. Alright, now we can draw all the possibilities that when you roll the die, right? These are 1, 2, etc. up to 6. These can be represented like this in a diagram. Alright, so the universe of possibilities, that is 1, 2, 3, 4, 5, 6 is drawn like this. Now inside this universe, let's draw event A, which is the possibility where a multiple of 2 is obtained when the dice is rolled. Now let's draw event B inside this universe. That's like this, right? Over here you can see that there is an intersection between event A and event B, right? Why is that so? You can see that one of the outcomes, which is getting 6, is occurring both in event A and event B. That's why we draw it like this, where there is an intersection between event A and event B. Alright, now let's mark these outcomes inside their respective events. So 2 and 4 is over here, 6 is in the intersection part, and 3 is over here. And what are the remaining events? We have covered 2, 4, 6, 3, right? So 1 and 5 remains. So they are drawn outside. And as we said, this over here represents the universe of events, that is all the possible outcomes. Alright, let's keep that aside. Drawing this type of a figure is helpful in many questions in probability. And this is something that we borrow from Venn diagrams, right? Now let's move on. Say we want to find out the probability of getting event A and event B. What is the probability of event A and event B satisfied, right? This can also be written as probability of A intersection B, right? That's written like this, A intersection B, and that is equal to 1 by 6, right? Because there is one outcome where A and B are satisfied, that's this outcome of getting a 6, and there are 6 possibilities, right, that can happen, which is the total number of outcomes, which is 1 to 6. So favorable by total is 1 by 6. That's the probability of getting A and B satisfied, or the probability of A intersection B. Alright, now over here you can see that what we did is, from the diagram it's very easy to understand that we just find the intersection. That's where A and B occur. Now what about A or B? What is the probability of A or B occurring? That would be the probability of A union B, which is equal to 4 by 6. Over here this stands for union. And what are the cases where A or B is satisfied? If you get 2, 4, 3 or 6, 6 is common, right? So 1, 2, 3, 4. There are 4 possibilities where A or B is satisfied, and we have seen over here there are a total of 6 possibilities that can happen. So the probability of A or B happening is 4 by 6, and from the diagram you can see that what we try to find out is this space, that is the whole area over here covered. How many events occur in this space? That's 1 2 3 4. We have 4 events, that's why we have a 4 over here, and in the universe we have 6 events, that's why we have 6 over here. So the probability of A or B happening is A union B, and that is equal to 4 by 6. Let's quickly revise. When you have AND, you find the intersection. When you have OR, you find the union, and the union is this space over here. The intersection is the common space, which is this space over here, where we have seen that we have only 6. Alright, now let's also learn one more thing about probability of A union B. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Let's see whether that is true. What is the probability of A? We have 3 favorable events, so probability of A is 3 by 6. What about probability of B? We have 2 favorable events, so probability of B will be 2 by 6. And what about probability of A intersection B? We have seen that we have 1 favorable event, so that's 1 by 6. Therefore, this over here is equal to 3 by 6 plus 2 by 6 minus 1 by 6, which gives us 4 by 6, which is exactly what we got over here. Alright, now over here, why is it that we subtract the intersection part? You can see that if you add A and if you add B, you will add this part over here 2 times, because it's part of A and it is part of B. But we want it only 1 time, because remember, only this shaded area is the favorable section. In that you just need to add the intersection 1 time. So because you added 2 times when you do PA plus PB, that's why we subtract 1 part of it. That's why we have to subtract probability of A intersection B over here 1 time. Let's move on. There is an interesting method with which we can find the probability of A and B occurring, that is P of A into P of B. Over here, this is applicable when A and B are independent events. Alright, now what do I mean with independent events? That is, the outcome A is not at all dependent on whether B is happening or not. Over here you can see that these 2 events are independent. Whether you get a multiple of 2 or a multiple of 3, you're just throwing the dice 1 time. Therefore, these 2 events are independent. The probability to get a multiple of 2 is 3 by 6, right? Because we have 3 favorable events, and 3 by 6 is equal to 1 by 2. Similarly, over here, the probability to get a multiple of 3 is 2 by 6, which is equal to 1 by 3. Now, if you multiply these 2, that's 1 by 2 into 1 by 3, which is equal to 1 by 6. And that's what we've got over here as the probability of A intersection B. Remember, probability of A and B is the same as probability of A intersection B. Let's discuss quickly one more example where this is applicable. Say you have 2 people X and Y, and they are trying to shoot at a target. The probability that X will hit the target is 0.2, and the probability that Y will hit the target is 0.3. Now the probability that X and Y will hit the target will be 0.2 into 0.3 as per what we have seen over here, and that will be 0.06. In this case also, you can note that X hitting the target and Y hitting the target are totally independent of each other. That is, if X hits the target or does not hit the target, it does not in any way affect Y hitting the target or not hitting the target. Let's do this question. In box 1, there are 20 red balls and 10 blue balls. In box 2, there are 30 red balls and 15 blue balls. 1 ball is taken from each box. What is the probability of getting 2 blue balls? Pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. So, in box 1, there are 20 red balls and 10 blue balls. In box 2, there are 30 red balls and 15 blue balls. Now, we are going to pick one ball from here and one ball from here, and we need to find the probability of getting two blue balls. All right, now what's the probability of getting a blue ball from box 1? This is box 1, this is box 2. The probability to get a blue ball from here is favorable events by total events, right? So there are 10 blue balls, so favorable events is 10 and total possibilities is 10 plus 20. So the probability to get a blue ball from this box is 10 by 10 plus 20, which is 10 by 30. Alright, what's the probability to get a blue ball from box 2? That would be 15 divided by 45, right? 15 is the favorable events and 30 plus 15, which is 45, is all the possible events. Alright, now we need to get a blue ball from the first box and a blue ball from the second box, right? Now whenever you have and, you multiply because these two events are independent, right? Therefore the probability to get a blue ball from the first box and a blue ball from the second box is equal to 10 by 30 into 15 by 45. 10 by 30 is 1 by 3. Similarly 15 by 45 is 1 by 3. So 1 by 3 into 1 by 3, that gives you the answer as 1 by 9. Let's do this question. There are 20 blue and 20 yellow balls to be put into two boxes. Alright, after putting the balls in the boxes, what is the maximum probability that can be achieved to get two yellow balls if one ball is picked from each box? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Over here, we have the freedom to distribute these 20 plus 20, that's 40 balls in any way we want in two boxes, right? But the criteria is, after doing this distribution, we will be picking one ball each from each box, and we should be getting the maximum probability to get two yellow balls. That's the question. Now, what is one way of distributing these 40 balls? We could have 10 blue and 10 yellow balls in each of these boxes. Suppose we go ahead with this distribution. What's the probability to get a yellow ball from this box? That would be 10 by 10 plus 10, which is equal to 10 by 20, right? Similarly, the probability to get a yellow ball from this box also is equal to 10 by 20. Therefore, the probability to get a yellow ball from here and to get a yellow ball from here is 10 by 20 into 10 by 20, right? 10 by 20 is nothing but 1 by 2. 1 by 2 into 1 by 2 gives us 1 by 4. Alright. Now, let's see another case. Say I distributed in this way. I put in this box just one yellow ball, right? And 0 blue balls, and all the other balls are put over here. Now, the probability to get a yellow ball from this box will be 1, right? It will be 100% because I just have one ball over here which is yellow in color. And what's the probability to get a yellow ball from here? That would be 19 divided by 19 plus 20, which is 19 by 39. And therefore, the probability to get one yellow ball from here and one yellow ball from here will be 1 into 19 by 39. And this is approximately 1 by 2, right? If it's 19 by 38, it would have been 1 by 2 exactly. So this is approximately 1 by 2. It will be a little bit lower than 1 by 2. And this is the maximum probability that can be achieved, right? Therefore, the answer is approximately 1 by 2. Let's do this question. An integer is chosen at random from numbers 1 to 100. What is the probability that it is a multiple of 2 or 5 or 7? Pause the video, give it a try, and then let's do it together. Alright, we are back. Let's do it together. Let's start with drawing this in a diagram so that we can easily visualize this. So to understand more of this, check any section where Venn diagrams are explained. Alright, let's move on. I can draw it in this manner where I have 3 circles. One is for the multiples of 2, the other one is for multiples of 5, and the other one is for multiples of 7. Now, let this rectangle over here represent the universe of events that can occur, which is any number from 1 to 100 can be picked out, right? So there are 100 possibilities. Now, the possibilities where we get a multiple of 2 or 5 or 7 is this shaded region, right? And the probability that we have to find is favorable events divided by total events, that's equal to the shaded region divided by 100. All right, let's quickly understand why this is so. All the multiples of 2 will come over here, right? For example, 2, 4, etc. All the multiples of 7 will be over here. For example, 7, 14 would be a multiple of 2 and 7, so it will come over here. 21 will be over here, 28 would be over here, etc. And the multiples of 5 will be over here. 5 is over here, 10 is over here, 15 is over here, 20 is over here, etc. So all the numbers which are either multiples of 2 or 5 or 7 will come in this shaded region. So we just need to find how many numbers are there in this shaded region. And we know the total possible outcomes are 100, right? Which is 1, 2, 3, etc. up to 100. So any of these 100 possibilities can occur. So the total possibilities are 100. All right, let's move ahead and try to find how many numbers are there in this shaded region. Let's start with the multiples of 2. How many multiples of 2 are there up to 100? We start with 2 into 1, 2 into 2, etc. up to 2 into 50, right? Because 2 into 50 is equal to 100. Now we can see that we have 1 over here, 2 over here, and this goes on till 50. So therefore, up to 100 we have 50 multiples of 2. This 50 could have also been obtained by doing 100 divided by 2. Alright, let's move on to the multiples of 5. How many multiples of 5 are there up to 100? We have 5 into 1, 5 into 2, up to 5 into 20. Because 5 into 20 is equal to 100, right? Now over here we have 1, we have 2 over here, and this goes on till 20. Therefore, we have 20 multiples of 5 up to 100. Now this 20 over here could also have been obtained as 100 divided by 5. Alright, let's move on to multiples of 7. So how many multiples of 7 are there? That's 100 by 7, which is equal to 14 if you leave out the remainder, right? And we can also do it as 7 into 1, 7 into 2, etc. up to 7 into 14, right? Because 7 into 14 gives you 98. Now that's the same 14 that we've got over here. So there are 14 multiples of 7 up to 100. All right, let's keep this aside. We have seen that we have 50 multiples of 2, 20 multiples of 5, and 14 multiples of 7. So can we say that the favorable cases are 50 plus 20 plus 14? No, we cannot say that, right? Why is that so? Because when we say that there are 50 multiples of 2 and there are 20 multiples of 5, we will be double counting the multiples or the integers which are both a multiple of 2 and 5, right? For example, over here you can see that this 50 represents the numbers which are there in this circle over here. Similarly, this 20 represents the numbers which will be filled in this circle over here, right? And you can see that there is an overlap between these two, right? So if we just do 50 plus 20 plus 14, we will be getting a number which is greater than the number of numbers which are there in this shaded region. All right, so let's find out how to go ahead from this point onwards. Let's start finding the common numbers. What are the multiples of 2 and 5? That would be the multiples of 10, right? And in 100 you have 10 multiples of 10. That's 10, 10 into 2, 10 into 3, up to 10 into 10, right? So there are 10 multiples which are multiples of 2 and 5. What about 2 and 7? How many multiples are there? You can see that there are 7 multiples which are multiples of 2 and 7, because when you want to find out multiples of 2 and 7, you just need to find out multiples of 14. So this one over here is 14 into 1, 14 into 2, which is 28, 14 into 3, etc. up to 14 into 7. 14 into 7 is 98. So 1, 2 up to 7. So we have 7 multiples which are multiples of 14 up to 100. Alright, now what about multiples of 7 and 5, right? Let's find that out next. multiples of 7 and 5 can be obtained by finding multiples of 35, and 100 by 35 is equal to 2. So there is just 35 into 1 and 35 into 2, because 35 into 2 is 70. 35 into 3 will be more than 100. So there are two multiples of 7 and 5 in the first 100 numbers. That's from 1 to 100. Alright, what about multiples of 2, 5 and 7, which is this region over here? We will have one multiple or one number which is a multiple of 2, 5 and 7, right? Because we just need to find multiples of 70. So you have just 70. The next one would be 140, which is greater than 100. So we have only one number which is a multiple of 2, 5 and 7. Alright, let's move on. Now, to find this shaded region, what is it that we have to do? We have to add 50, 20 and 14, and from that we need to subtract 10, 7 and 2, and we need to add 1. Let's try to understand why that is so. When we add 50, 20 and 14, what are the areas that get double counted? Let me mark these 1, 2, 3, 4 areas so that we can understand this better. Let this area over here be 2A. Let this one be 2B. Let this one be 2C. And let this area over here be 3. Alright. Now, when we add 50 plus 20 plus 14, this area and this area gets added only one time, right? But 2A will get added when you add 50 and when you add 20 for multiples of 5, right? Therefore 2A is added 2 times. Similarly, you will see that 2B is added when you add the multiples of 2, which is 50, and when you add the multiples of 7, which is 14. Therefore 2B, which is this area over here, is also added 2 times. Similarly, you can see that 2C is also added 2 times. Alright, and what about 3? 3 is part of multiples of 2, multiples of 5 and multiples of 7. Therefore 3 gets added 3 times. Alright, now when we subtract 10, 7 and 2, what is it that we are subtracting? 10 is the multiples of 2 and 5, right? That would be this area over here, which is 2A plus 3, right? So we are subtracting 2A and we are subtracting 3. Similarly, when we subtract 7, which is the multiples of 2 and 7, we subtract 2B and 3, because this is the area where we get 7 over here, 2B plus 3. So that's getting subtracted. So let me write that over here, minus 2B minus 3. And when we subtract 2, we are subtracting 2C and 3. So minus 2C minus 3. We can see that 3 is getting subtracted 3 times, 1, 2, 3, right? So that and this part over here gets cancelled out. And 2A, 2B and 2C is getting subtracted 1 time. So this 2 over here will get cancelled out. 2 minus 1 is 1, right? So we are left with these 3 areas and 2A, 2B and 2C, right? So we can see that this area so far is not accounted. That's why we need to add 3 to this. So when we do this, 50 plus 20 plus 14 minus 10 minus 7 minus 2 plus 1, that gives us 66 as the answer, and that is the number of integers from 1 to 100 which will be there in this shaded region. Now we know that probability is favorable events by total events. We have found that favorable events are 66. That is, there are 66 numbers from 1 to 100 which are either a multiple of 2 or 5 or 7. So the probability is equal to 66 divided by 100, and 100 is the total number of outcomes possible, which is 1, 2, 3 etc. up to 100.